Hi, everyone. Welcome to our webinar session today. We are going to give people just another minute or so to jump in and we'll get started. All right, let's kick it off. Thank you, everyone, for joining us today. We're excited to be going through our content of advanced CI and CD with you today. Before I kick it over to Conley, our presenter, I just wanted to go through a couple of housekeeping items. First off, this webinar is being recorded, so you can plan to receive that here in the next couple of days in your inboxes. So you can look forward to that. In addition, if you have any questions that come up throughout the session, please put those in the Q&A portion of your Zoom window. We'll have time to answer those throughout, and Conley will have some time at the end to answer some of them live as well. And with that, I will kick it over to Conley.
All right. Thanks so much, Taylor. Hopefully you can hear me okay. And let me make sure I'm sharing the right screen. That's probably a good start. Okay, there we go. Thumbs up, you can see it. All right.
We got you.
So yeah, thanks. Appreciate that, Taylor. Thanks so much, everyone, for joining us today. I wanted to say first and foremost that I want to start with the most important thing here, which is you all. This presentation and the work that Taylor's team does is all in hopes of providing you more value for your GitLab subscription. So that means if you've got a question, definitely don't hesitate to put that in the chat. I'm going to save some time, about 10 minutes or so at the end for Q&A. So we'll address some of these questions live. And then we also have a couple of folks from GitLab that are going to be answering them throughout. So don't be shy. So my name is Conley Rogers. I'm a senior technical account manager for our strategic enterprise accounts. I'm coming to you from Atlanta, Georgia. Before joining GitLab, I was an engineering manager at Verizon, where I led a team in charge of SDLC modernization. We would publish and educate teams on best practices, how to utilize insights like the Door 4 and CI/CD type analytics to have more productive conversations with their business counterparts or product management teams. That's a little bit about me, and I wanted to dive into what we're going to cover today. So today we're going to go through sort of a quick recap on CI/CD, especially with the GitLab flavor of CI/CD, some terminology, the pipeline architectures that are most common, as well as a couple more advanced ones. Variables are super important and foundational, so we're going to hit that so that you can understand rules and how to control your pipelines better. And then controlling when your jobs run, how to deal with artifacts as you're building code, you're storing it in artifact storage in those binaries that you're going to need for testing, deploying your code, and then assembling pipelines from components. So kind of modularizing your CI/CD jobs to be most effective and save a lot of time. A couple things that are sort of like out of scope is that detailed setup and configuration for CI/CD and runners. We've got a course just on that. So you can look that up in our professional services catalog, as well as in-depth usage, best practices for project management. We've got a course just on that. And then if you are a systems administrator and you are just trying to understand how to spin up GitLab, troubleshoot it, upgrade it, etc., we've got our own sysadmin training for that as well. So those are a couple of things that are sort of out of scope today. Just wanted to get that disclaimer before we dive right in. All right, let's get into it. So let's start with what we call the GitLab flow. It's probably sounds like a branching strategy. GitHub flow, GitLab flow, Git flow are all branching strategies, but this is more of a process. And I know this is a webinar about CI/CD, but I wanted to start with the bigger picture in mind, because beyond the technology of the pipelines itself, it's a process to ensure that you get the most from your investment in GitLab, as well as to improve collaboration across your engineering team and other personas like security and change management as you actually are writing and deploying code. So that's why we wanted to show this first. So this is the GitLab flow process that we recommend for DevOps teams to follow while using GitLab capabilities within a concurrent development lifecycle. So you start with sort of defining and managing the requirements, the desired issue that you're working on, whether it's technical debt issues, whether it's features and bugs, or whether it's a security risk compliance type issue. That's all in the backlog. As soon as it starts to become in scope, ready for a sprint or ready for development, you assign that issue. And this is where the fun begins. Instead of creating your branch and then just kind of going off and making commits on that branch and pushing that back to server, we actually encourage and even have prompts in the UI to immediately create a merge request after you create that branch. So this works for more than just the GitLab flow branching strategy. It works for many branching strategies. It's kind of agnostic of that. So the reason that we do that is so that it becomes evident to the rest of the team that, yes, I picked this issue up, and yes, I also have a work in progress merge request. So you can immediately start to bring in the right stakeholders so they can see when you push code, which will automatically trigger our CI/CD pipelines that by default, unless you configure it otherwise, so that every change is running basic linting and static analysis, and you're getting really fast feedback loops. That's just from the developer perspective. Once it's ready to be reviewed by, say, like a senior developer that has maintainer privileges, then they can do so and be brought in with a single app mention, right? And they can see the full history of commits, pushes that had taken place right there in the MR. They can also see if that pipeline has green checks across, which tells them it's passed the required quality gates. Then it'll spin up a live ephemeral instance in like a non-production environment, if that's the type of application that you're developing, and that it can do such, so that we can perform dynamic security testing on a running instance and test for cross-site scripting and dynamic attacks like that. Once it's looking good, it's passing all those checks, the appropriate approvals and separation of duties would actually come in at this point. So if there's any kind of findings in those scans, it may require an additional person from a security group to come in and either approve it or review it. And then you land in your default. So that would be once that merge request is accepted, it runs the CD workflow for deploying into a release and packaging that up into a release and then deploying into your environment of choice, whether that's staging, then to production, what have you. So I wanted to start there just to give the bigger picture. And now kind of zooming in on the CI/CD elements of what we just saw. So the CI pipeline, that's where you're building your application. Behind the scenes, we're using GitLab runners, which I'll talk about in just a second. Then you're running unit and integration tests on that package to make sure that everything is looking valid. You can also look at a live preview. So that's getting into that review app, live preview of your development branch before you even send it to your default branch and before merging it into a stable version of your application. Then you can deploy to multiple environments like staging and production. We support advanced features such as canary deployments for this, for incremental rollouts. Then you can monitor performance and status of your application as well, all within GitLab. So let's look at the terminology that GitLab uses for describing and defining CI/CD. The largest component of that is the pipeline itself. So this is a set of one or more jobs and it's going to be organized into stages. And a stage is that next piece down. So a stage is a local grouping of jobs that pertain to a phase of the pipeline. So they can be run in parallel, which improves the performance of your flow in that pipeline. So this is things like a stage would be build, test, deploy. Those are all stages. And then the job itself is the actual task that needs to be performed. An example of that would be an npm test, Maven install, bash scripts, shell scripts. So that's really what makes up, and that's what you're defining in infrastructure as code using YAML files to do so. The environments is where you're going to be actually deploying. So it points to a deployment destination. This is all in one file, version and stored in the project that it pertains to at its most basic function. The last piece is the GitLab runner. That's the infrastructure piece that executes everything you see on the left side. You can have as many runners as you like, as many as you need to handle the volume and load from your engineering department. You can even use your PC if you're trying to test certain things out, or you have very niche use cases. Just keep in mind that means that members of the project will be using your laptop as a runner. So not made for production, but if you're just trying to get a certification and get very familiar with setting up GitLab CI, it's a great option to not have to go provision something in the cloud or with your OS teams. So the pipeline architectures that we're going to cover today, as we're doing this, ask yourself, how can I use these concepts to improve my pipeline performance and functionality? We've got 5 different flavors that we're going to dive into, starting with just a basic vanilla pipeline. We're going to get into directed acyclic graphs, parent-child pipelines within the same project, dynamic child pipelines, and then the 5th one we're going to hit is multi-project pipelines. Starting with the simplest, a basic pipeline is just a series of jobs that run independently. You can put them on different runners, but even that would be kind of more advanced than basic. Usually they're just going to be all on the same runner. And then all the jobs in the stage must complete successfully before proceeding to the next stage. This is what that would look like. So basic build, test, deploy pipeline here with the jobs defined. So you can see like if the build itself is successful, you then start to run a series of tests, probably some unit testing and integration testing here. There's some logic, the allow failure to be true so that the pipeline can proceed even though it failed those tests. That is optional and you can configure that. And then for deployment, it could be it's a common practice around deploying to environments that you have to have the right permissions. A lot of requirements for separation of duties say that the person who pushes the code can't deploy the code. So this is how you would handle a scenario like that, so that when you are deploying into a production or even UAT or staging environment, that it waits for somebody with the right permission to click that manual intervention to deploy it. And then other options, when delayed, when on failure, and when always. It's just more ways to control the flow of a pipeline. If you've got hard requirements to always run something, to run it on failure, or to delay running a job. Second one that I wanted to mention is a big architecture improvement that we made some years ago, but very foundational to GitLab CI, is the idea of a needs clause, or what it looks like is a directed acyclic graph, a DAG. So this is how you start to define the flow. So the pipeline flow, so that you can run parallel jobs, and you can even move on to the next stage if certain jobs haven't finished. So the more that you can run concurrently, the faster that job or that pipeline can finish as a whole. So This is great for moving on to non-dependent jobs so that you can keep the flow moving and you don't get hung up waiting for every job in a stage to continue before moving forward. So that's what the needs keyword allows you to do. So it defines those dependent jobs. And this is kind of what that looks like. Just an example of using the needs keyword. You can define the job relationships. So if GitLab knows the relationship between jobs, it can run everything as fast as possible and even skip into subsequent stages when possible. So in this example, you have an application deploying to both Android and iOS. So these are not dependent on each other running. So if you wanted to create a needs keyword here, you can speed up the total pipeline. If say the Android build completes faster than the iOS, then it can move on to running all of the tests on that built binary instead of waiting for both to complete. This is a visualization. This is pretty complicated, not going to lie, but you can start to see the flow logic by using our UI to look at the relationship between jobs. So as you mouse over it, it's going to highlight the dependency paths involved. And then you can also click on multiple paths and it's interactive. So if you're trying to figure out, you inherited a project that's very complicated and you're trying to just figure out what's triggering what, this is a visual way of doing so. Okay, the third architecture we're going to look at is the parent-child pipelines. So within the same project, this is very useful for running non-dependent, long-running jobs. So things like code scans or building and deploying the front end, back end services separately. That's when this would start to become very useful. So it combines, if you combine this with the directed acyclic graph pipelines, you get the benefits of both. So it is best to kind of use every tool at your disposal to improve the efficiency of these pipelines. And it's useful to branch out long-running tasks into those separate pipelines. So that's why the parent-child architecture is very useful. So along the lines of simplicity, this feature allows you to call other YAML files from within the same project. So that can solve for issues that you may be facing, like the staged structure of a pipeline, where all steps in a stage must be completed before the first job and the next stage begins. That causes arbitrary waits and slows things down. It also solves for configuration for the single global pipeline. That could become very long, right? If you've got one really long global pipeline defined, it could be hard to manage. So you can start to modularize by using more than one CI YAML within that same project, and then have this kind of parent CI YAML that can call those other YAML files, right? So it just becomes cleaner to manage, to read, so readability improves there as well. And then imports with include keyword increase the complexity of the configuration and create the potential for namespace collision where jobs are unintentionally duplicated. It can solve and help with that. And then even like the pipeline user experience can become unwieldy with so many jobs and stages to work with. So that's more on the readability side. So you can see here in the example that we've got build, test, deploy, as well as downstream pipelines, all within the same project. So you may be deploying multiple microservices and you need a different language and a different pipeline to handle each microservice. That's when the parent-child pipeline becomes very useful. So that those downstream pipelines that are triggered can be running separate, all from within the same project. So this is sort of the behind the scenes how to write the file for this parent-child pipeline for, say, a monorepo that's deploying those microservices, like I was just showing in that example. So it'll run the job if there are changes in those files. So you can define, for this stage in particular, to only run it if there's changes in this project-1, any file within that project. And then you can include files from elsewhere within the project, so that it's going to include the appropriate downstream YAML code to run that project correctly. And then finally, the strategy to depend means that it holds this pipeline until the other pipelines have finished. So that's sort of like the code behind the visual that I just showed. Number 4 of 5 is the dynamic pipeline. So this is going to be generating pipeline configuration at build time. It uses the generated configuration at a later stage to run as a child pipeline. And it's useful to have a single pipeline configuration with different settings to support a matrix of targets in architectures. So instead of running a child pipeline from a static YAML file, you can define a job that runs your own script to generate a YAML file dynamically, which is then used to trigger a child pipeline. This technique can be very powerful in generating pipelines targeting content that changed, or to build a matrix of targets in architectures dynamically. Right, so you can see this test GitLab CI YAML file is being generated dynamically, and places a generated YAML file in the job artifact store, then references it later to actually run the pipeline that it has generated dynamically there. And the 5th architecture we're going to cover today is called the multi-project pipeline. So this is when you have a project that sits sort of on top of other projects that can then trigger pipelines across, because everything up to this point we've been talking within the construct of a single project or a single code repository. So there's like 3 main use cases for using this we're going to talk about, but you can specify specific branches. You can pass variables to downstream pipelines. If a downstream pipeline fails, it will not fail the upstream pipeline, so that's a benefit. And useful when deploying large applications that are made up of different components that have their own project and build pipeline. As the title infers, you can set up GitLab CI/CD across multiple projects so that a pipeline in one project can trigger a pipeline in another project. You could visualize the entire pipeline in one place, including all cross-project interdependencies when you set this up within the GitLab UI itself. So we have a job called a bridge underneath the test stage. Okay. And what it does is triggers a pipeline in the project path from branch main, and simple as that. But there are some other great use cases for this. Sort of the simple A to B is the first of the 3, where a project that just triggers the pipeline in another project to run, such as a code project triggering a rebuild of its documentation. So that's like a simple A to B configuration for the multi-project. The other one is like an orchestrator project that manages the build and deploy of multiple other apps, and is sort of that parent project that houses the control logic. So that's orchestrating, a large deploy across many subsequent repositories. And then the third one is called versioning, but it's really, any variable that you need to pass to downstream projects. This is a great reason to use the multi-project pipeline. So, say you need to pass the version number to the downstream project, you can do that with a multi-project pipeline. So that's just kind of showing the anatomy of how to build one of these. The job with the trigger is referred to as the bridge job. And you can specify the project and the branch appropriately. You can do wildcards as well. Okay. Wow, a lot of good stuff here. So you can actually see the UI for when it shows you that downstream graphic within the GitLab UI. So it's helpful to visualize everything that parent job is kicking off. And so with that, we have covered the 5 different architectures of GitLab CI. If you want to learn more about that, you can go to our documentation. It's just GitLab architectures. So you can kind of read more examples, more YAML code that you can copy paste and start to play around with. But now I want to get into the anatomy and components, starting with the variables. So CI/CD variables are a type of environment variable. You can use them to control the behavior of jobs and pipelines, store the values that you want to reuse, and avoid hard coding values in your GitLab CI YAML file. You can use predefined CI/CD variables. We have a very large list of those that are predefined, and you can just use as you need to, or you can define custom variables. In terms of using these and injecting them into your pipeline, you could do it a number of ways through the UI at the project level, group level, and instance level. You can set variables, and we'll talk in a sec about sort of the hierarchy of which ones take precedence if it's defined more than once. All right, so you can see within the project, you can add variables. You can also enter them for the pipeline run, and you can even use URL parameters. It doesn't have to be a hard and fast, hard-coded string there. And then within the CI configuration, of course, you can define these variables, both custom and the predefined variables. So an inherited variable is a variable that's added to an artifact in the build job script. This artifact is handed down to other jobs as inherited variables. These take precedence over variables defined in the YAML file. And then in terms of processing the order of operations, which ones take precedence. So going from bottom to top, the top being what takes the highest precedence. So if you've defined a variable manually in the UI or in an API request for that given pipeline that's been triggered, that's going to take the highest precedence. Going down to values configured at the project group and instance, with project coming first, group second, instance third. So if it's an instance variable and you have a project, it's going to choose the project variable if there's a conflict. And then values inherited from jobs in previous stages would be third, values in the YAML block, in the variables block is fourth, and then values from GitLab predefined variables being the fifth. So for defining the flow logic, you need rules. So if you're thinking in terms of Jenkins, like Groovy scripts to manage, how and when the pipelines are triggered and run. So that's sort of the equivalent here. So I'll talk about the syntax of the rules, but starting with the ways that you can trigger a pipeline to run, it can be from new commits to a merge request. It could be on a branch. It could be on a new tag. You can trigger these manually through the UI. If you need to run a report or a freestyle type job, you can trigger through the UI, an API, or through a schedule. So if you're needing to run something regularly on a 24-hour, 48-hour schedule, you can also do that. And then the variable for this setting is CI pipeline source. And we'll show some examples where you can change that pipeline source or you can disable it running on merge requests if you need to. So using that variable CI pipeline source is how you would control when pipelines are run. The basics of a rule and sort of the building blocks here is that you would have the job itself being defined, and say that only on web run would you want this job to be kicked off. Then you need to create the rules block with the rules keyword, and then you can define your if statements to reference variables, including predefined ones, as in this case, like the CI pipeline source is web. So if you're using the web IDE, then you can trigger this job to be run, otherwise it won't be. And then as it claims, this job will only run when the pipeline is kicked off from the web form. Simple example is just going to echo a string that says that this job will only run when the pipeline is triggered from the web form. So very simple, but you can start to see the construct of a job, a rules block, an if statement, and then a subsequent script or action. So a quick reference if you wanted to sorry, I think my headphones cut off. Taylor, can you hear me?
Yep, we still got you.
Okay, thank you so much. Sometimes it just does that. So this is a great slide to screenshot if you want to just kind of screenshot this, save it away for reference. So the clauses that you can choose from, you saw the if statement. You could also do, if changes are made to certain files, only then do you run the subsequent script. So that's very useful for improving performance of your pipelines. And then the operator to say if, this is pretty standard for writing any kind of script, the results for when that operation is true, and then what happens as a result. So the when options you can have as always, never, on success, etc. So this is kind of the building blocks of writing a rules so that you can ensure that things only run when they need to. That saves time, it saves resources, and improves efficiency. So I threw in some tips and tricks for speeding up complex pipelines earlier. The directed acyclic graph is a great way of doing that. But let's take a look at some other ways now that I've covered rules and variables. So the first one is setting run rules. This is one of my favorites right now because it allows you to say, these files didn't change, so I don't want to run this job, or I only want to run on certain branches, right? So it allows you to say what jobs run when so that you can save time, especially as a GitLab CI YAML file can be over 1,000 lines. You certainly don't want that running every time. Setting up the cache. So cache setup, the files live on the runners, and it enables use of the existing built item without rebuilding it between pipeline runs. Tags are especially useful as you can ensure the correct runner is being utilized for the right deployment. Parallel testing. So this one's probably self-explanatory, but I wanted to make a point to mention this. As you bump up the number of tests that can run in parallel, assuming you've sized your runners to handle that, that's going to improve performance. And then the before script. So if you have a lot of, say, container preparation buildup in a before script, it might be a sign that you need to convert that section into like a Docker file in a new repo and have your own build container. But if there's other types of scripts and it's just checking for certain settings, this can dramatically accelerate builds where there are a lot of build dependencies to layer on before running your code. So one last thing I would say is trying it both ways and compare and contrast to see which ways run fastest for you. I think that's just a great rule of thumb so that you can get used to using more complex concepts, but then you're very pragmatic. You aren't just trying to use it because it's new and cool, but rather it's actually improving that performance, and you can measure that and see it between different pipeline builds. Okay, let's go through a couple examples of rules in action. So if you're trying to control when merge request pipelines run, right? So if you don't want to run your CI pipeline every time a merge request event happens, you can set that rule. If you do want it to run, then you can use the CI pipeline source on merge request event, or CI pipeline source as a push to that branch. So those would then trigger it, unless you kind of say otherwise that you don't want to use that. So in this example, pretty simple, but that's just saying that these are the sources in which I want to run my pipeline. All right, another example here where you don't want to run a job if it was scheduled versus triggered automatically is using the CI pipeline source for this, and then saying that on a merge request event, you don't want it to run. And then on a CI pipeline source schedule, you also don't want it to run. Otherwise, this job will run if the previous stage was successful. So this can just, again, save time or even control the types of tests and jobs that won't run if it's a schedule. If it's a scheduled job, or if it's, say, you wanted to kick it off from the UI, and you don't need it to run a whole slate or a whole block of code to save time. So you're only trying to scan like a binary that you're pulling in as a dependency, and you just need to run like a dependency scan. You don't need to do the full SAST, and you don't need to do secrets detection, etc. You can cut out some of that and dictate, don't run this block if it's triggered manually through the UI, something like that. So I wanted to share that as a second example. And then as the third example, if you're trying to control when scans are run based off of the contents of that commit or of that merge request, this is how you can go about doing it, right? So if I've got Docker files and scripts for Dockerizing my application that have changed, then, okay, I'm going to want to run my container scanning, and I'm going to want to run infrastructure as code scanning, like IAC. Otherwise, I may not need to run IAC because it's all Java code that was changed and it's not infrastructure code. So I can dictate that if these files aren't changed, then I can skip it and save time in my pipeline. So that's why I think that this changes is a really good one to save time and speed up pipelines here. But yeah, what this one is saying that it needs a manual intervention to run this if it senses a change to Dockerfile or any files in Docker scripts. So it would be a manual job. The fourth example is a sort of delayed job. So this job is going to run 3 hours after triggered and will be allowed to fail. So if you've got, say, like a long running either script that's custom, long running integration tests, something that is going to take a while, but that feedback isn't necessary immediately, then you can run like a start in or delayed 3 hours so that it runs either at night or at a time when it's not going to block progress during the day when you're working on this branch. The workflow rules control when the entire pipeline will run, and they're outside of the job definitions we've mainly been talking about up to this point. So here we see if the commit message contains whip, then it won't run the pipeline. And if a tag was applied, then it also won't run. Otherwise, it will. So you can control, if I'm just saying, hey, this is WIP, I just wanted to check it in and maybe have somebody on my team look at it, but I don't actually need to run the pipeline on it, then this is a technique that you can use to kind of control the workflow. And then another example for workflow, for variables is that the variable in this example, Docker file, will be set differently based on the rules. So you can see that here, and it will always run, by using the keyword when always. The second to last topic I wanted to get to is artifacts, right? So, as you run pipelines, especially CI, you're building and publishing files. Those generate files, binaries, packages that you'll use for deploying your application. It also generates artifacts for reviewing test results. So we're going to talk about managing those artifacts for a minute. GitLab allows for saving artifacts in local or object storage. You can then use them in subsequent jobs. And then you can use the rules logic of exclude, depends, and when to control what is added and when to determine if an artifact is stored or not. You may not need to store it. It may be something that you just need in the job to run your tests on, and that's good enough. So that's some of the keywords around, like using exclude to limit what is added, using depends to limit what gets downloaded on subsequent jobs, using when to determine if artifacts will be stored or not, and then the expire in to determine when artifacts will be destroyed. Very good to have, especially for stuff like test results. I think those are only stored for 48 to 72 hours by default. You have to change that expire in if you want it to live past that. And that's just to save space and costs for storage. But you can set these as you need to. Where to find and download artifacts in the GitLab UI. So within the pipelines page, you can see that you can download the artifacts, whether that is the compiled code, whether that is the test results. You can do it on the jobs page within a specific job, and then the artifact browser, if you're using our package registry, you can download them from there. If you're using something external, then you would just be sending it off to something like Artifactory. And so it wouldn't be in our artifact browser, but otherwise though, you can see within the pipelines and the jobs themselves, and you can download those and review the test results if you need to. As far as administration goes, in a self-managed GitLab instance, job artifacts can be stored in local or object. Artifact expiration times can be configured at the instance level. And then artifact downloads fall under our GitLab access control. And it's probably pretty small, but I'll just tell you right now, download and browse job artifacts, guests, all the way through reporter, developer, maintainer, owner. They can do that. They can browse and download job artifacts. So good to know so that you understand who has access. That's assuming they already have access to the project and group. So it's not just anyone willy-nilly, but that's the permissions that can do this. Here is some of the container and language specific package registries that GitLab supports. Container, of course, dependency proxy, and then some language specific package registries, all the common ones, npm, NuGet, Go proxy. So you can see that. And we've got a docs page. So if you go to our sites, you can look under packages and find the full list and details here if you want to kind of dig around a little bit more. And lastly, a quick example. So by default, all artifacts from all previous stages are passed on to the next stage. But you can use the dependencies parameter to define a limited list of jobs or no jobs to fetch artifacts from. So to use this feature, define dependencies in context of the job and pass a list of all previous jobs from which the artifact should be downloaded. You can see here in this example that we've got a build OS X and build Linux stages. So in order to run the test scripts that we need to, we've got to make sure that we're using the right artifact, right? So that's where the dependencies of build OS X come into play. So for the test stage, that's what you would write for that as a dependency. And then likewise for your Linux testing to take place, you're dependent on the build Linux artifact there. So this is just an example of how you can choose when and where to pass artifacts through, and you can have multiple generated and pass to specific jobs in the next stage. The last but super crucial topic is on includes and extends. Super powerful. If you take away anything from this, I would say this is a big one. Just in terms of scaling GitLab CI/CD, this is a must-have. So that's where we're hitting it here towards the end, and it's building upon the concepts that we've covered. An include statement is how you bring in external YAML files to your GitLab CI configuration. It's helpful because it allows you to abstract common components and improve readability. It can save you a ton of time if you utilize other templates. GitLab comes with many templates as part of your install. So all of our out-of-the-box tests like SAST, secrets detection, if you use an include statement, that's all you have to do. It's going to pick up the appropriate language your code was written in, and it scans for all of the SAST rules. In that example, secrets detection, same thing. It's not language dependent, but you just add the include statement for secrets detection, and boom, it's going to take care of the rest. It's like 2 lines of code. So that's why it's so powerful, and it saves a lot of time. There's different methods for doing this. I talked about the templates, right, which are provided by GitLab at the very bottom here. But you can also, include a file from your local project repository. That's sort of the parent-child example I gave in the architects, 5 different architectures of writing a pipeline. So that's the local include if you're just trying to find it within your own project file. If you want to include a file from a different project repository, and then remote, if you want to include a file from a remote URL. So if there's something just publicly out there on like public GitLab.com that you want to pipe in, it needs to be public visibility, but you can do that. And here's the examples on the syntax for writing those includes. Extends is another way to improve efficiency and eliminate needs for rewriting or writing lengthy code in your YAML file. So extends is similar to YAML anchors, but it's a little bit more flexible and readable. So I did want to touch on this. It'll allow you to enhance and reuse configuration sections. So if you know about YAML anchors, you know that it's used to duplicate or inherit content across your YAML file, but they're only valid in the file they were defined in. So that's where extend comes in. You can inherit up to 11 levels. We say, no more than 3 just for performance reasons. And then what it does is it merges the configurations and from the respective job into your current one. And that's going to save some time. So that's kind of the example you see here with the dot tests in our spec becoming one single job that's been extended from the template job. This also works across configuration files when you use and include with and extend. So in this example, you can include an external include file with a nice little script. So you can include that in your GitLab CI YAML. So now, instead of having to copy, paste, and complicate your GitLab CI YAML, you can create a job that extends that .template job with the script echo hello, and just say what image to run it on. So simple example, but powerful feature I wanted to just make sure to call out there. And I think we're kind of spot on. We've got about 10 minutes here. We have indeed covered a lot of ground. And I love that section about components and reusability. It's a great place to leave on. So we're going to pause now, and I'm going to kick it over to Taylor because we have a poll. And we're also going to open the floor up for some questions. Taylor?
Great. Thanks, Conley. Yeah, I just opened up that poll. Just a couple of quick questions. We'd love to get your feedback on today's session. And with that, there have been a couple of questions come through, Conley, that I'll pose to you to answer.
Sounds good.
The first one here, what's the difference between Jenkins and GitLab CI?
Yeah, this is, kind of the incumbent, one of the original best ways to run automation for your projects was with Jenkins. And so fundamentally, we approach it different than Jenkins, which is a plugin based model where you're trying to maintain, install, upgrade all the appropriate plugins to kind of extend the features of Jenkins. And so that's got inherent risks and overhead that you have to keep upgrading, you have to maintain, which can be very intense, especially at scale. You need basically a couple SREs to do this properly, versus the GitLab way of going about CI, which is we're going to give you those templates out of the box. It's not plugin based, it's infrastructure as code. So you can check that into your project repositories, run all the same linting and testing on that you would your actual code. So it just facilitates more reusability and collaboration across the enterprise. And so very fundamentally different ways they came about in different eras as well. So those are probably the biggest differences I would highlight. There's also some similarities just in terms of you do have to have GitLab runners, which are very similar to GitLab agents, which is the infra to run those pipelines on. So there is some knowledge transfer that will serve you well. That's my point.
Great. Thank you. Next one that came through here. How can I run this across my full list of applications and enterprise?
Yeah, this is like what we handle, day in and day out. Our customers are trying to ensure that they're covered across the full slate of applications. In case a log4j or an audit comes up, how can you ensure that you're getting the same rigor across hundreds or thousands of projects? So we didn't go into it too much in this talk, but there is a whole section of GitLab just focused on compliance and making sure that a set number of jobs, scans, you name it, runs across your full slate of applications. So I'd encourage you to look into the compliance framework and the compliance pipelines. Those are two ways that you can apply a label to your project systematically, and then that will pipe in a GitLab CI YAML that runs ahead of the local project. So you can put in there anything you want, and the developers can't change that unless you want them to, but you probably don't. And so there's ways to make sure that they can't change that, but then they have the freedom to run anything they need to around building, testing, deploying their application. So it's kind of that perfect balance of, compliance with staging, but freedom for developers to still do their job efficiently. Topic for another day.
Awesome. Great. I think there's just one more that I'm seeing here. What's a good training path to become an expert?
If this is your day-to-day job and you're like a DevOps engineer, say trying to write those templates, keep them up to date, sort of that golden CI image, if you will. Like there's definitely training resources that GitLab provides. We've got our own certification path that you can take. for becoming GitLab CI intermediate and professional, as well as, just getting the gist of best practices in DevOps. I highly recommend the AWS DevOps Engineer Professional course. Different tooling. It may even make you appreciate GitLab more. It certainly did for me, but it's very valuable knowledge to have if you're trying to take this as a profession and go deeper and deeper. Then I'd recommend those different options, starting with GitLab's own training, so you get all the nuances. But broader speaking, there's great content in other tools and platforms too.
Awesome. Thank you. Well, I think we're getting close to just about here at time. So appreciate everyone's time today. Thank you, Conley, for the great presentation. And thanks everyone for the great questions that came through. I think this was a really engaging session. So with that, we will wrap up, and like we said, we'll be sending out the slides and the recording here in the next day or so. Have a good rest of your day, everybody.